What's the correct pronunciation? Is it ATtiny or ATtiny?
Don't even bother yelling, Mr. Spacesuit. Welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Dan Maloney, staff writer for Hackaday and community engineer for Hackaday.io.
This is episode 149. Today we'll see a Ballerina bot that balances, Flexures that track cat food, a PCB going under the knife, and an ATtiny doing the 555. This is our first week without Mike Stitch at the helm, and so far so good.
Yeah, it was for me. It was a case of meet the new boss, same as the old boss, because it's not like you're not a known quantity, but it's good to have you in the big chair. It was good to have Mike in the big chair for so long too, and I mean he's the guy who brought me on, so I have a lot to thank him for. We had a lot of good times over the last almost 7 years now for me, and glad he's still out there, because I know he's going to be out there lurking and making sure that we're all doing what we're supposed to do.
I still bet he won't get the What's That Sound contest.
Notoriously bad at it.
He can hear this now, I'm sure. Well, I pick hard ones. It's on me, actually, I think. I blame me.
Me too.
So what's news this week?
The big news is this Log4j vulnerability that's all over the place.
Yeah.
It got enough into the public consciousness that my wife kind of said, hey, what is this hack they're talking about, this log hack thing? And she doesn't roll in these circles. And for it to, pop up in her feeds means that it's starting to get out there in the zeitgeist sign. I don't know that I did a particularly good job explaining it to her, because I don't know that I particularly understand it, but it's an Apache. It's an Apache module, I guess, that's been used for decades for anybody who's doing logging. And they found this vulnerability that's been there apparently all along, and showed up as a 0-day. But now, and I saw an article yesterday, I think it was, where it's actually on the Perseverance rover or on the Ingenuity helicopter, or both.
Oh, no way.
Yeah. So I don't know if that spells bad news or not. I mean, I thought it was bad enough having to patch my Minecraft loader. I guess the people at NASA might have a little bit more to worry about with their vulnerability than I do with mine.
My guess is a lot fewer people have access to their robot than people do to your Minecraft server, though.
I'm thinking it has a certain amount of security by isolation, maybe, or it's a little bit air gapped.
It's on kind of a different network.
That's quite a vacuum gap to breach.
Exactly. And speaking of space news, the James Webb Telescope. What do you know?
I know I'm nervous about it. After all these decades of delays and $10 billion, the thing is finally packed up and ready to go. I believe at this point it's sitting atop its booster. It's already been integrated. It's fueled. All the hydrogen tanks and thruster tanks that are going to do the station keeping when it gets out to that Lagrange point are filled up, and it's ready to go on its 30 days of extended slow motion deployment of the solar shades and the mirrors and the antennas and all that stuff.
Makes me nervous just thinking about it.
Well, like you said in the meeting the other day, I think the launch probably is the least of the worries. I'm knocking wood here.
Yeah.
But it's all the millions of things that could go wrong. Everything that has to happen over the next 30 days is a single point of failure. And like when we toured it, Tom Nardi and I toured the JWST in the clean room back during the SuperCon in 2019. He said that they've never been able to open the sunshade in the clean room without having it be damaged. I hope that's different when it's on its way to its final place, but we'll see.
Well, they only have to open it once, right? I mean, if it works, it works, and you only have to do it once. So
yeah,
here's hoping is right.
This is a journey into sound.
What's that sound?
What's that sound?
Okay, it's time for What's That Sound? I'm going to play a cryptic, surprising sound. Dan is going to try to guess what it is. If he can get it right, well, he doesn't win a t-shirt because he works here. But if you can get it right, you write us in and we will draw among the correct answers to see. Have a listen.
Man, that is a tough one. I don't know. It's got sort of an underwater sound to it, like sonar or something. I'm stumped.
Let's see. I'll tell you, it was a fairly recent recording. I think a month or two ago.
Oh,
If that long even.
Are we getting some clues from current events, perhaps?
Maybe.
Maybe it's something to do with a submarine.
I definitely hear the underwater vibe, but it's not underwater.
No. Oh, okay. Now, stumped. I'm
Stumped
calling
is
it.
good. All right. Well, if you out there know what it is, feel free to write us in. If you get it right, we will pick among the right answers, and the lucky winner gets a Hackaday podcast t-shirt.
Good luck.
All right, it's time for the hacks, and I would like to start off with a robot build by Hans-Jürgen, aka Time Expander. This is a self-balancing robot, but it's also got arms that push itself back up after it falls over. And in the beginning of this video, Hans is explaining that, when you start off with a self-balancing robot, before you get it tweaked, it falls over a lot. And so he was thinking, maybe I'll just put arms on it to push it back up. That'll make my life a lot easier. And then you start thinking about that control problem of having arms at the top of a robot that's supposed to self-balance, and where it pushes itself up and then it suddenly swings them up like this. I don't know what. I just landed my gymnastic maneuver, arms straight up in the air kind of pose. Watching the video of it actually successfully working is really awesome. Watching the video of it failing to push itself up and catapulting itself over, which he has a lot of outtakes at the end, is kind of convinces you that maybe this wasn't the simplest way. Maybe him just going and picking the robot up would have been easier.
Yeah, I've always been really impressed with these self-balancing builds. It's kind of funny that, to me, that this is like a little bitty segue.
Yeah, exactly.
The whole self-balancing thing really caught on because of the segue in a lot of ways. And then everybody started miniaturizing it. And you get things like this, which are, considerably smaller than a segue. But then you've got the other end of the spectrum where you're getting bigger with these things, like one of the Boston Dynamics robots. Maybe it's the one that looks like an ostrich.
Yeah, they've got a two-wheeled one.
Handler or something like that. It does the same sort of motions where it's got it overshoots its balance point and then comes back. And like you said, tuning on the PID loops in this one is really pretty amazing. And I think it was actually pretty cool that it's done through a phone. That seemed to be pretty impressive to me. I would figure that there would be some latency, and you would have trouble actually hitting the tune points, if you will, but I guess not, because here he is doing it.
I wanted to talk about all of the crazy extra features on this thing. Besides pushing itself up with its arms, it's got an ESP32 on it. It connects to your home network. It displays a QR code with its IP address so you can connect to it and tweak it over your cell phone, over the network. And one of the things it does is let you tune the PIDs over the phone. And so, if you've ever tried to do one of these balancing robots, they wobble around a lot. And that wobbling is controlled through a PID loop. And getting that just right depends a lot on the robot's geometry. So you kind of just have to do it empirically. And flashing the robot over and over and over again is nobody's idea of fun. I think it's just really sweet to have them on 3 little sliders on your cell phone here, to up the P, up the D. And the results are actually pretty darn good. The last thing I want to talk about this robot, if you're thinking of building your own, they're not so hard anymore. The IMU part has become tremendously cheap. And then 3D printing makes it a lot easier too. Here, one of the coolest features is he designs a slot to put, I think they're Swedish, heavy coins into up at the top, because these things, when they have more inertia, it's easier for them to balance. So he stuffs the top of it with a slot exactly cut out to hold a stack of heavy Swedish coins. It's just a really sweet idea that caps off a fantastically sweet little design. Good to look at if you're thinking of doing your own balancer.
And fits in the palm of your hand.
And looks so good when it flips up.
I like the ta-da at the end. Like, ta-da, I did it.
That's totally a ta-da moment.
My first pick is Digital Painting on an iPad with Real Brushes by Richard Green. This is it's really hard to categorize. It's art, it's computers, it's a little bit of Bob Ross because you get the chance to make your own happy little trees, or in this case, he's making happy little rocks. But the way he's doing it is really, really interesting. It's on an iPad. The iPad's on a bit of a stand that keeps it at an angle. And in front of the iPad, as if you were going to have like a keyboard on your tablet, and that in sort of that area is a Fresnel prism. The camera on the iPad is looking down and seeing the prism. And then when you interact with this prism, this art area that you're the canvas, I guess you'd call it, with brushes or rollers, I guess, or rags or your fingers even, if you've got a little bit of water on them, the camera manages to see the areas that you're touching and what's left behind as if it were paint. And then software in the iPad does a little magic and says, okay, I'll fill in that area with the last color you selected, or I'll make a little gradient from this side to that side. And you end up having what looks like a painting on the screen. It's got a lot of organic quality to it because as the water beads up, it kind of goes in makes different patterns that the camera sees, and the app does a really good job of incorporating that texture into the final product. It kind of leaves me asking, if you've got the skill to use real brushes, why aren't you just painting on canvas in the first place? But I like when we talk about, the great art that Joe Kim does and the way that he does it completely digitally.
Yeah.
There's huge advantages to doing it completely digitally, but also having all of this expressiveness of what a real brush does when you're working paint on canvas.
I guess it uses frustrated total internal reflection to do the sensing of the liquid on top of it. And because it's like literally sensing the brush or the hand or whatever through this liquid, it just looks so organic, you said. And that's exactly right. And it gives you instantly ways to play with it, like with finger painting or something else. There's a lot more texture and effects and whatever you can get than even with the absolutely best pen stylus tablet thing. I mean, there's just no way to compare the kind of, I don't know, hands-on nature of the funny shapes and textures and whatever else you can make. It looks like a blast. And then you couple that with the power of, a graphic drawing program to do interesting things and duplicate things and undo and redo. And I think that part is actually super powerful.
Yeah, I think so too. And I kind of wonder as I'm watching it, because there's a couple of video moments where you can kind of see what's going on in direct light. So you're not getting the point of view that the iPad camera is getting, but you're kind of getting a different point of view. And you can see the water beating up a little bit and all that. And it occurs to me, like, what if you use something that had a different surface tension than water? What if you use a little oil or maybe alcohol or something like that would have a different refractive index, and maybe you could get effects? That would be something to experiment with. I don't know if he did that or not.
He does this one where he's doing it ends up being a coastline or something, but it's a wet rag, and he just puts the wet rag on there, and the places where the wrinkles in the rag make contact with the surface end up looking like this rocky coastline cliff thing. And it's just that's a really pretty cool effect. And there's just there's a level of organic detail, and then the person can influence control over that's just very real and not, computery.
Watching them do those rocks was like a digital version of Bob Ross's knife with the little bead of titanium white and the phthalo green and all that stuff, and having them just squish it onto the canvas, and then all of a sudden you've got a mountain. And it was as magical as that, I think. I thought this was a really good hack.
What do we know about the software running on the iPad? I
think it's something that he came up with. I believe so. It's
Lightstrokes app, available for free from the App Store.
Oh, nice.
Well, heck, how cool is that?
Yeah.
All right, my next hack is absolutely impossible. Andrew Zonenberg, PCB microsurgery, puts the bodges inside the board. Andrew is no stranger to Hackaday. He's done a bunch of really interesting IC decapping experiments, and he also does PCB reverse engineering by passing a mill in successive layers over the board to like take the different layers off of a multi-layer PCB. He's using a lot of these same skills here. He's helping Femtoduino debug a 6-layer board with internal vias. It's a little microcontroller on a little PCB that fits inside your USB port. And so it's got, the 4 little USB-A fingers and not much more sticking out of your computer. The thing is tiny. It's the same form factor as the FOMU. This is a microcontroller version of them, if you know what that is. I'll throw links in the show notes. The problem is this is a prototype version, and there are some problems with the Gerbers, and there is a short and a missed connection, and they're deep inside the 6-layer layout. This board is incredibly complex, and so the question is, how do you get a green wire in there? And the answer is in this long Twitter series where Andrew drills down to the, whatever it is, 3rd or 4th layer, cuts a trace down there, and then solders the tiniest little bodge wire you've ever seen from one of the 2 pads down there back up to the top surface that plugs into the USB port. This is some incredibly fine micro machining. Like, I don't even know what size that drill bit is, but there are some of these pictures where it's all done with the microscope at 40x, and you're like, I can kind of see what's going on there. And then he zooms out, and the hole looks like it's, a lot bigger. And then you realize it's a USB connector. And the whole thing is even tinier than you thought it was.
Yeah, the fact that the entire repair takes up just a tiny fraction of one of the pads that the USB connector uses. And the fact that he's legitimately measuring it in micrometers.
Yeah, of course.
The just mind-shattering how, and he actually made a mistake. He said that he was told that it was a 1.6 millimeter thick board. It was actually 0.8 millimeters thick.
Oh, no.
He's blasting down through it, gets too far, and ends up cutting a trace to an internal via or something like that. He messed something up, and that he had to fix that too. But the problem when I wrote this one up was, how am I going to show this in any way that is, what kind of photographs am I going to show? Because they're photomicrographs and they've got a limited depth of field, and you can't really tell what's going on. But then again, if, like you said, if you zoom out all the way, then you see, oh, okay, there's a little fleck of something on the PCB, and that's where he's doing his work. But that doesn't tell you a story. So
right.
I had a hard time trying to illustrate this one. It really is one of those things where you just got to go and look at the Twitter thread and thumb through all those pictures and just let your jaw drop, because wow, someone actually did that. Yeah, and it worked. There's supposed to be a second part coming up where there were 2 problems on that board, and he, as far as I know, he had only fixed the first one by the time I wrote this up. But looking forward to the second one, because that one was promising to be harder to fix than this one. Just mind blowing.
And a lot of our commenters were wondering why the heck you would go to this insane level to fix up a little board. And if you already have the tooling worked up like Andrew does, it's no problem. Just throw it on your micro stage milling machine that you've already been playing around for taking the layers off of PCBs. But if you don't have that, this would seem like an incredible amount of labor just to fix, a hole on the tiny little $10 board. But Andrew does point out that this is the prototype for a multi-$1,000 run of these things. And rather than respin the whole thing up again and risk having more problems in the final version, this is the chance to absolutely be sure that there's no problems in these Gerber files, get them completely rock solid fixed, and make sure that the fixes you think you found are the fixes that actually fix everything, so that when you do run the full production run, everything works. This is a heroic effort, but it's not out of place if you're thinking of it as standing in for fixing up an entire production run of these tiny little boards.
Yeah, and I really liked his idea of mechanical tomography. So just taking the board and lapping it down on abrasives bit by bit until you see, okay, 1 layer, 2 layers, 3 layers, and get down through those layers and be able to do a stack up with those and see where the
Yeah.
connections are. And the last layer he did, where he's down to basically the back of the board from where he started, got it, was so thin that it was transparent.
Yeah.
And a beautiful photograph of that. Just a treat. You guys go check it out. It was really cool. Next up, you can always use an ATtiny instead of a 555. This one is kind of related to the classic "Why didn't you use a 555" comment that we often get on Hackaday. In this case, Shrinav Palakurthi is too lazy to just go get a 555, which is impressively lazy since there's about 1 billion of them made since 1971. But instead, he had an ATtiny 85, and he said, well, look, 8 pins here, 8 pins there. Heck, we'll just throw a little code on this and put it to work. And that's exactly what he did. He executed the primary logic, I guess you'd say, of a 555 in code. Did it on the most ridiculously over engineered, or the most ridiculous overuse of a number of components to get something done, but all in one chip. I think it was more of a joke than anything else, or just a can I? Especially, by the way, the guy is just giggling at the end about
he can't keep but cracking up.
About how much fun this thing is and how ridiculous it is. I think there's 2 versions of this. In the original write-up from Jenny, he was using one that kind of had a couple pins reversed relative to the configuration of the 555 itself. So you'd have to make accommodations for that in your circuit. But he also seems to have made it pin compatible by squashing an ATtiny 85 out flat, so the legs are out flat, and then bending the legs back around the other way, and then putting a jumper on, and it ends up being pin compatible at that point. At least I believe that's what I read.
Yeah,
it looks pretty hairy when he did the did the bending back, because there's like a crease line there in the lead frame that wants to. The metal wants to break right there, so he had to throw some solder on, but still he managed to get it done, and he claims he can just plug this little beast in and have it act like a 555.
Yeah, I've dead bugged a lot of dip chips before just by folding the legs out like that, and I will tell you can do it once. And if you do it again, the metal fatigue gets you every time. So you've got one shot to bend them into place, and if that fails, you bend it again, it's going to fall right off. Actually, right now, our 555 timer contest is going on. You should check it out. I hope this is in there. My God, did we mention that in the write-up?
Yeah, he put it in there. Yep.
Okay, good man. We will throw a link to the 555 timer contest in the show notes. Oh, yeah. And Jan Gidon points out that you can actually make an ATtiny out of 555s as well. And so then you could take a bunch of 555s, make an ATtiny, load this code into them, have it emulate a 555, and you'd be good to go.
It's like an Inception for 555s.
All right, my last hack this week is a video by Amy Makes Stuff. Fabulous Flexure mechanism makes for resetting cat calendar. Amy loves Flexures, and actually I think we've both got to hang out with her at SuperCon 2 years ago when she had this milled out Delrin Flexures toy, all of the different mechanisms she'd come up with on a piece of wood board, walking around wearing it around her neck and like inviting people to play with them. It was really awesome. If you ever get the chance to play around with these things, they're all like super tactile, and I understand why she thinks they're super fun to play around with. In this case, the device she made a long time ago was a cat feeding sign. She and her housemates want to feed the cat twice a day, but anyone can do it. So the question is, how do you keep track of who's fed the cat and on which day? So the thing has a spinny wheel with kind of a ratchet on it that shows you which day of the week it is. And then it's got 2 toggles. And these are all done with flexures. So they're all done just by exploiting the geometry of the milled out Delrin, in this case, to flip into place and hold in place, and then flip back and hold in place when you flip it back. But then the question was, can you design a kind of over-the-top Flexure setup so that with one motion, you can clear both toggles and rotate the day wheel to the next day? And the answer is, of course, yes. And this video is one half her making this crazy Flexure mechanism, and the other half is her kind of coming to terms with a cheap CNC router she got given and figuring out how to make parts like she's already made before, but using a different machine. And I know she's done a lot of work with laser cutters, and from listening to her, she's done work with other kind of higher grade CNC machines. And this one is one of those little desktop CNC mills with a not very powerful spindle. She actually manages to stall it out on brass and I think makes some headway through aluminum, going super, super, super slow. It's like way underpowered for the job. And that's also interesting. I thought there were two reasons you might want to watch this video. One is if you think Flexures are cool, and the others is if you're thinking about buying one of these like cheap budget CNC mills. This might give you pause if you're thinking of doing anything heavier than like PCB milling with it.
I have to confess, I do not remember Amy at SuperCon 2019 at all. And that's really strange to me. If she's walking around with a busy board full of Flexures around on a lanyard around her neck, I think I would have remembered seeing her. I don't know where I was if I missed that, because those mechanisms, I think she flashed it a little bit in the video there, and I would love to have seen those, because these are, like you said, they're all like little cool tactile things, and I thought this was a really great project. I like the simpleness of it. I mean, hey, let's go back to the other one. Why not just use a 555? Well, why bother when you can do something, completely mechanical that does the job and does it elegantly and attractively. It's a good looking little build. Me personally, I've got a cat that reminds me that it hasn't been fed by jumping from the headboard onto my face at 3 a.m. So I don't need this.
No problem.
But I guess it'll work for some people. For me, not so much. Again, with like you said, this, like, it's a 2-part, 2-for-1 kind of thing where you get the Flexure bit, which is really cool, and then the review of the CNC machine, and it kind of shows you some of the pitfalls. You're just not going to necessarily get what you think you're going to get out of the box. That said, a lot of the comments on this one kind of ran toward, think you're using the wrong kind of end mill. You really need a high quality one. It'll make all the difference in the world if you're trying to optimize something like this. And that's great that you pick up those kind of details that our readers have from hard-won experience, either through work or hobby or whatever. I really appreciate that part of it too. It's not just her experience with it, it's everybody else's experience with similar situations.
She does say at the end that this kind of a super low-end mill does make a lot of sense if you want a project. Like if you want something that you can improve, maybe get it a better spindle, maybe, improve this, improve that. There's lots of ways that you can take this kind of basically solid small frame and make a workable machine out of it. I think that's part of what a lot of the people in the comments are kind of reacting to. Like, I've done that with some horrible 3D printers. Like, you could take a crappy ANET A8 printer kit and make a good printer out of it, but you have to invest sweat and blood in it. And her point, I think, is that if you don't want to do that, this probably isn't for you, especially since it's only going to be able to kind of cut thin things anyway, and that you might be able to do better on a laser cutter. And then if you're going to do something, significantly thicker but soft enough that you could mill it with this machine, you could probably do it with a 3D printer and just print it out directly, et cetera, et cetera. It does put it in kind of a weird niche. I would and did myself step up to a significantly bigger machine because you can do bigger, cooler things with it, but it means paying 3 times, 4 times as much money straight out the gate. So if you want to buy something small, see if playing around with a CNC mill is right for you, and then it gives you lots of room to upgrade it along the way. I guess that makes sense too, right?
At this point, I'd be happy for any CNC machine.
Well, you can pick up one of those cheap Chinese 3018s for $150.
Yeah, and that's ridiculous.
They are horrible. But for $150, it's a pretty good amount of horrible. Like they're not
Well,
horrible.
it's
but they're
kind of like
horrible.
it's kind of like the K40s, right? The lasers that
Exactly.
everybody was picking up for what, $300, something like that.
Yeah.
That you're going to get a horrible laser cutter, but it's a horrible laser cutter is probably better than no laser cutter.
And you're going to have to do your own exhaust fan, and you're going to have to figure out air assist, and you're going to have to enlarge the bed, and you have to do all this work on it. But a lot of people have done this work before you and documented it well. So if you enjoy like digging into this sort of thing, if you want to hack on a laser cutter or hack on a CNC mill, here you go.
Chances are somebody's done it before, and you're going to find out about it, especially if you're hanging around in Hackaday. My last pick is from Nick Build, a slim 7400 Logic VGA board for all your retro needs. It's always a treat when Nick drops something new because you never know what it's going to be. Nick is not only prolific, I mean, we see stuff from him probably pretty darn near every week. He's also very eclectic. I mean, it can go from machine vision project to a robotics project to something silly to something serious. So this time it's for the Vectron VGA Plus, which is basically a VGA card for retro computers. And I think his basic goal was to make it generally applicable to anybody who's doing retro computing, discrete chip computers, 6502, 8080 kind of builds where you're building them out of discrete chips, that kind of thing. Generally, we've seen this kind of project before. It's nothing new to be able to generate VGA signals for these retro computers. But the new thing here for Nick is to kind of put it all in one place and to make it a commodity, I guess, rather than a kind of an ad hoc thing. And it sure started out ad hoc. If you take a look at of what the breadboard looked like, it was a disaster. I shouldn't say it was a disaster. It was what it had to be.
It's a horrible rat's nest is what
it's
it is.
Okay. I'm trying to be gentle.
I look at that picture and I'm just laughing because, I've had those on my desk from time to time. And yeah.
How do you even?
Tom's right up here is that's when you have to make a PCB out of the thing.
Yeah. It's nothing we haven't seen similar before, like with a Ben Eater's VGA adapter that he built for his 6502 project. With him, it's more about education. This is how it works, and he breaks it down bit by bit, literally bit by bit, gate by gate, and will throw on a chip to do a thing that, the next thing that needs to get done. And so these projects kind of grow and grow and grow. The breadboards end up being a little bit neater, but still, they're quite expansive. Nick just wants to get rid of all of that and get it down to one board that he can kind of, throw into a project anytime that he needs to. And I think he's done an admirable job here. Looks great. The board looks great. As Tom says, you could probably shrink it down some, but why bother if this is good enough compared to, where it started? It's much neater. It's much easier to use. I think what he basically says that he simplified it by getting rid of some of the logic chips, or rather he got rid of some of the logic chips by replacing that with memory and basically just put some of the stuff in memory that would have to be done kind of tricky like with your 7400 logic chips. It's nice that it sort of rolls this all together and kind of takes some of the mystery out of the VGA process for people who are doing retro computer builds.
All right, my first quick hack this week is Wii meets its end in breadcrumb jail. Sonic Tim has managed to wedge a Nintendo Wii into a toaster, which is kind of an homage to the classic Nintoaster, which had a Nintendo in a toaster done by Vomit Saw back in 2008. This project is 5 years in the making. I don't know why you need a Nintendo Wii inside a toaster, but as Arsenius, who wrote this up, says, it's better than putting a toaster inside a Nintendo Wii. Next up, Google's T-Rex game ported to the ESP32. Danko Bertovic has taken that funny Hop the Little Dinosaur, slightly better than Flappy Bird game and ported it to the ESP32. In particular, this one's running on the LilyGo TTGo display module, which has power management and an ESP32 on it and a color LCD. So it's a one-stop shop for playing jumping dinosaur until you get bored. And last up is absolutely ridiculous, a programming language to express programming frustration. Kyle M73 has written that's a capital H, capital H, capital H programming language. This is an esoteric programming language in the style of where all of the different commands consist of the letters H, 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 and H, but with different capitalizations. An A is the signal for the beginning of the code, and an exclamation point is the symbol for the end. So every program written in this language looks like whether it runs or not. Good luck debugging.
My first quick hack is 3D printing delivers glass eyes in record time. This is just another one of the many, many examples of where desktop manufacturing, new manufacturing methods is being used to revolutionize everything in medicine, including prosthetics and reconstructions. This one basically is production of what we call a glass eye, is a prosthetic eye for someone who's lost one. It can take up to 6 weeks for a traditionally produced glass eye to be available for the patient, and that's a long time to wait if you're worried about your appearance, which most of us are. Glass eye makes a big difference for someone who needs it, and now with this technique, it can be made in only 3 weeks. Still a long time, but a lot less than originally. The reason I kind of twigged to this one is because my mom recently had a crown done, a dental crown done, and she was in and out in 2 hours because the dentist invested in CNC technology that can make the tooth right there in the office. Maybe advancements in this will get it down where a person can just go to a prosthetic office, get an eye printed, and walk out with their new look. Next up, controller swaps can save an HDD if you do it right. This one is interesting because we've all been in a position where we've had a hard drive fail and we realize that we haven't had a backup in however long. And if you did have a backup, you don't know where it is. And everybody knows that story. This one is an extreme version of hard drive recovery by transplanting a chip with calibration data from the bad drive to the controller of a new drive. I was put in mind of the Xbox repair I tried to do the other day, which didn't work out too well for me, but still, it's an impressive fix. And going down to the chip level like that and having this little hack was kind of interesting to watch and makes it seem like something that anybody could do. The last one is differential probe clocks in at 100 megahertz and $200. Personally, I'm terrified to use my scope on any line-powered gear because I've heard that that's going to end in instant disaster for both the device under test and my scope. I don't really understand that fully, but I understand that I spent a lot of money on my oscilloscope and I don't want to see it go up in smoke. A differential probe, I'm told, is the answer for that. I understand that. I also understand that you've got to usually shell out a lot of money for a differential probe, but this one came in at a price tag of just about $200. Certainly something to look at if you're in the market for differential probes. Maybe it's just time to build your own. I do question, maybe at $200, maybe it's just better off to get a scope meter instead that's battery powered and you won't have grounding issues. What do I know? I've already got a scope, so maybe spending $200 on a differential probe is the right way to go.
All right, now it's time for our Can't Miss articles. These are long-form articles written by our own Hackaday crew. And my first pick is Stephen Dufresne's The Real Science, Not Armchair Science, of Consciousness. And this is a really neat look at how modern research is starting to crack the problem of how humans are conscious. You know, this is one of those things where consciousness is not super well identified, identifiable, quantifiable. Stephen says that it's really subjective. You know, do you feel like you're thinking about something? Yes or no? While we can do super precise measurements with like EEGs and MRI, fMRI techniques to figure out what's going on in your brain, you can't tell necessarily if the person's actually conscious of what's going on or not, or can you? And that's what this article is about some really clever tricks, essentially by like flashing super short duration images up on the screen, what used to be used for like sketchy subliminal advertising.
Read more, Hackaday.
Can now be used to put up images that your brain recognizes unconsciously but are so short in duration that they don't make it over into your conscious brain. This technique is known as masking in the literature, where they show you one image, they show you another one for a super brief period of time, and then the first image again. So if you notice there's been a change, is the question, and can they tell this from looking at an EEG of your head in real time? And the answer here is that they can. When the middle image, when the masked image is shown just long enough, there's an entirely different brain response to it. And it consists in kind of a wave of brain activity going across your cortex after about 200 milliseconds and going on for another kind of 200, 300 milliseconds. So, half a second of thinking about it, which actually sounds about right from my own inner head experience of the world. Anyway, it's really cool because what this does is this gives them a signal in the EEG for, has this only been seen by the person's subconscious brain, or has this then filtered up to the part of the cortex where we actually do the thinking about things? And that's really cool to see actual measurements of what it looks like in the brain when you kind of realize something.
I think when I read this, the first thing I thought about was years and years ago, a friend of mine who's an entomologist, and he was working at the psychology department of some university. I forget. I think it was in Seattle, because he studies social insects, and so that kind of models how people think. And I went off on some sort of theory that I had about how kids learn and stuff like that. And he just sort of patiently looked at me and nodded. And at the end, he pointed to his head and he said, "Let me tell you something. We don't have the slightest idea how this thing works up here."
Yeah.
And that was coming from a position of authority. He was working in the business of trying to figure out how thought happens. And now that was probably 20, 25 years ago, something like that. And it sounds like maybe he's now wrong. It sounds like maybe we're starting to finally get an idea of how this gooey thing between our ears actually works. The thing that gets me about this, though, is the length of these propagation delays, if you will, of between an event happening and your perception of it being obvious by watching an EEG. 200 milliseconds is huge. That's a ridiculously long ping time, if you will.
Yeah, right.
So how do we deal with that internally? I mean, I guess we're all equally disadvantaged when it comes to perception delays just by the electrochemical nature of what's going on in your head. So maybe it just all evens out in the wash, but those numbers just seem ridiculously long compared to how fast we have to act and react in the world. I don't doubt them, but they seem really, really much bigger than I would expect.
I think we're a lot more distributed systems than a lot of people think. I think you think of the brain as kind of like everything's going on up there, but there's all these like little autonomous loops going on and, in your periphery. And I remember from a course in perceptual psychology in college, the professor gets up there and he's like, so this is about how fast nerves conduct. And then this is the time delay you can expect from your fingertip to your brain. And then suppose your brain has to act on it and return something back down to your fingertip. And the response time on these things is ridiculously slow. And that's why there's all these local loops and reflexes and things like that. And I think a lot more in the 90s, people were realizing that the visual system is a lot more, guessing at things and then having them be confirmed than people thought originally. People thought originally, image hits your eyes, it goes through the visual processing, you figure out what it is. But because there's such a lag, you're guessing what things are going to be all the time and getting this either confirmed or refuted by your experience of the world. And that's how we compensate for having this ridiculous lag in our system. Like, I've been hanging out with some high performance quad racer type people, and these are people who can tell the difference in reaction time in kind of the 20 millisecond, 30 millisecond range on these quads that they're flying ultra fast through gates and stuff like that. A big part for them, and they will all tell you this if you ask them, they're all anticipating when they need to make that next move a little bit. And we were talking about, the latency in these different radio links because I'm a nerd. And the thing that really kills them actually is jitter. So it's changes in the latency that really confuse them. And that's because they are out there kind of anticipating what the quad's going to do when they do the next reaction. And it's this bizarre kind of disembodied thing that is surprising that people can do that until you think about how slow our own nerve system is. And we're doing that all the time anyway.
A lot of things that we kind of think of woo-woo kind of stuff like intuition or deja vu or things like that, they're probably all going to boil down at the end of the day using, measurements and techniques like Steve explains in this article. I think that's all going to come down to actual neurochemistry, electrochemistry, things that are actually physically going on in your head. We just don't have access to them yet. We can't figure that out. And this looks like these techniques get us closer to being able to really put a finger on how this thing works up there. For my can't miss article, I picked Jenny lists the seductive pull of an obsolete home movie format. Now, what could be further from the gee whiz stuff that we do every day than a trashy old 8mm movie camera from maybe the 70s or something like that, before the age of VCRs, long before the age of smartphones. If you wanted to record what was going on and you wanted moving pictures, you needed to do it in film. And these were the only tools available for that. Jenny picked this thing up at a thrift store. It's a Fuji P300 from 1972, she says. Surprisingly, it was in really good shape, as a lot of these artifacts would be, because they were really lovingly taken care of because they were so darn expensive relative to the time. The piece is really just sort of a teardown, but it also is sort of a trip down a technology memory lane, which I really appreciated. The first thing I thought of when I saw the camera that she got was a camera that I've got somewhere in the house. I went looking for it before we started recording, but I couldn't find it because it sounds great. It's a completely mechanical 8mm camera that my wife's aunt had. They took it on trips to Germany and things like that. So there were these great films that were in it that were already developed, and you could kind of hold them up to the light and see these pictures from the 60s. And it is really great to, family history thing. But the camera itself is completely mechanical, one of those wind-up clockwork things. Everything about it just sounds and feels so solid. It's hard to explain because the things that we have today don't feel like this thing. When you wound it, the clicking was creamy, I guess would be the only way to describe it. It was just this beautiful clicking, satisfying sort of feeling. And when you press the trigger and you could hear the shutter and the reels and everything going in there, it had this soft whirring sort of sound. You're great. It just like a mechanical marvel in your palm of your hand that would be just a treat to have as a device. But now that it's past its prime and you can't get film for the things anymore, just a great artifact to have as a sort of a reminder of what we had to do things when we didn't have CCDs and memory chips and, little tiny lenses and all ththese things. In Jenny's article, first of all, she does a nice kind of a summary of different film formats from the early days, the 8mm format, the super 8mm format, which everybody's kind of familiar with probably. 8mm was different. It was basically just 16mm film that was split in half the long way, spliced together, and all the sprockets ended up on one side. She did do a teardown of this device. Normally, I'm not a big fan of teardowns of quote unquote vintage technology. But as she points out in here, there's nothing special about this device. It's going to be just more useful to her if she sticks a Pi cam in it and uses it that way. Right now, it's just a mechanical device that doesn't really serve a purpose. So why not gut it to the degree that you need to put a Pi camera in there and make something useful out of it? So I just thought it was kind of an interesting piece because of all the nostalgia in it and reminding me of these mechanical ways of doing the things that we don't do anymore because we've got easier electronic ways of doing it. There's pluses and minuses to that.
Yeah, that's exactly what I loved about the teardown is that Jenny says the surprise comes in how little in the way of electronics it contains. Aside from the light sensor and moving coil, that's it. And that's true. This thing is a kind of triumph of electromechanical engineering from back in the days when the electronics were the expensive part, and then doing all of this fine, tiny machining was actually easier and I guess cheaper than making the electronics do the same thing. And I think that's really an interesting take on it. I totally get it, the reluctance to just gut the thing insides of this thing and slap a Pi in it. I do understand that for sure. But her point is that, you know, if each cartridge of film costs $50, and then she has to manage to get them developed, and then she has to find some way to project them, like, that is more dedication than she's got for this $5, you know, junk store find. The only way she's going to get any use out of this thing is to put a Raspberry Pi in it. And, you know, I'm sold on that anyway. It's her junk. She can do what she wants with it. But more to the point, I do think that it's a piece of commodity gear, but it's really shocking how cool this like old school commodity gear can be. You know, in the 70s and the 80s, making these like super tiny little consumer mechanical devices was at its apex. And boy, it's a lost art for sure. Nowadays, you open up anything consumery at all, right? And it's a green PCB with a bunch of little black chips in it. And, you know, what, do I say I miss it? Maybe not, because I don't have any chance of repairing the one or the other. And at least with a modern recorder, you don't have to replace these stupid rubber bands on the inside.
Yeah, I think that's the thing that strikes me. Like, I'm looking at the picture right now of the moving coil aperture inside this camera, and I think I'm seeing maybe a dozen screws.
Yeah.
And some are Phillips, and some are straight, and some have plastic or wax or something that seal them, and some are brass, and some are steel, and every single one of those screws was put there by a human being, with skill and precision, and it was the only way to get things done when this was built. And you got to look at that and say, okay, nice job, guys. You know, it was well done. We've got better ways of building things now. Maybe not better ways, different ways of building things now. The lost art of someone who sits in front of, you know, a station and puts together these things and it's gone forever. And maybe that's good, because that's kind of a crummy way to make a living, probably. But then again, there's some craftsmanship there that we don't see in a lot of things anymore. And personally, it's terrifying to pull a camera apart. So kudos to Jenny for even trying. It's a little bit easier when you don't really care too much about, you know, whether it's going to work when you get it back together than it is if you've got, you know, a camera that's irreplaceable and, you know, you need to make a repair inside. I've always been terrified of those repairs, especially cameras, because there's so many fiddly things. But yeah, I really enjoyed this article. I thought good job to that for a $5 thrift store find, to get a lot of mileage out of it and a lot of nostalgia.
That brings us to the end of this week's Hackaday podcast. If you have any tips for us, please write us in at the tips line, tips@hackaday.com. Any comments about the podcast, write us up at editor@hackaday.com. And until next week,
keep on hacking.
None of this we can use.
This one. Where are we? What am I trying to say?
Quick stretch and then quick hacks. Vomit saw. Thank you. Lovely.
My first quick hack is 3D printing.
First up on my list is, and my first one, Dude, I've messed this all the way up.
I think we're done with that one.
I think that's the perfect ending. I don't have anything else to say.